Welcome to Unit 3 on two-variable statistics. This is Lesson 5, Fitting Lines. Our learning goal for this lesson is to find the best linear model for some data that is given to us. We have two learning targets today. Learning target number 1 is for you to feel comfortable saying, I can describe the rate of change and y-intercept for a linear model in everyday language. And learning target number 2 is for you to feel comfortable saying, I can use technology to find the line of best fit. Our first practice problem says technology required. Anytime we see that, we are going to be using the Desmos.com graphing calculator. They give us a table of x and y values, and number 1 tells us to use graphing technology to create a scatter plot and find the line of best fit. So, like I said, anytime we see technology required, you should be thinking about the Desmos.com calculator. Now, on this calculator, in order to put in a table of values, you want to hit this plus sign that says Add Item. When you click it, it'll give you options for function expressions, notes, tables, folders, and images. So you want to choose Table. When it populates, it'll look like this, but it'll have empty slots, and you can go ahead and put in the values from your table. To save time, I went ahead and I took the values from our table in the practice problem, and I already input them to the table here on the Desmos calculator. Now, once you have these values in here, you can see the scatter plot that it created. Here it made all of the dots green. Now, if we wanted to zoom in on this and get a better look at it, it would look something like this. In order to find the line of best fit, what we're going to do is click right below the table to open the next line. And when we type these, notice they're calling it x sub 1 and y sub 1. So you're going to type in the slope-intercept form of this equation. So we want y sub 1, which you get by just typing y and 1. Then, because this is a line of best fit, we are approximating the fit. We are going to use a tilde instead of an equal sign. And you can find that tilde by hitting Shift, and then there's a key usually right next to your 1 on your computer keyboard. So y sub 1 tilde, then we want mx sub 1 plus b. So we're just typing in our basic slope-intercept form of an equation. And you can see that it has drawn the line of best fit in here with this black line. And right underneath it, you can see what your m value is, and you can see what your b value is. So when you write this, you're going to say your line of best fit is y equals, for m, we have 1.08937 x plus b, which is 15.58811. So now we have our line of best fit. For number 2, it wants to know, what does the best fit line estimate for the y value when x is 100? You can just substitute 100 in for x and solve. $1.08937 times 100, all we have to do is move that decimal point 2 spots to the right. That becomes 108.937. Now we can add these together. 108.937 plus 15.58811. And I'm going to go ahead and round this. We'll say 124, 52511. So we'll say that's approximately, since none of the numbers in the table had decimals, we will round to the nearest whole number. The 5 tells us to round the 4 up to 5, so it would be approximately 125. And if you look in the table of values, if I were to put a 100 in here between the 97 and the 101, this 125 does fall between the 127 and the 120. So that does seem like a reasonable approximation. If you have any questions about how to solve this practice problem, please use class time to ask for further clarification before we move forward. Our next practice problem, again, says technology required. So again, we will be using the Desmos.com graphing calculator. It gives us a table of x and y values, and number 1 asks us, what is the equation of the line of best fit? Round numbers to 2 decimal places. So we can go to the Desmos.com calculator, and just like previously, to save time, I have already put in the table of values. Remember, if you're trying to put in a table, you are using this plus sign that says add item, and you're just choosing table. Then you will fill in your values. Now, if I want my line of best fit, I am going to type in a generic slope-intercept style linear equation. So that is y sub 1 tilde, for is approximately, mx sub 1 plus b. And now you can see the green dots are the scatter plot, and the black line is the line of best fit. They wanted us to round to 2 decimal points. So when we write in this equation for number 1, we're going to have y equals, the slope is negative 2.45, and the y-intercept is 11.83 when we round. So that is how we can use the graphing technology to get the line of best fit. Number 2, what does the equation estimate for y when x is 2.3? Round to 3 decimal places. So y equals negative 2.45 times x, we're going to substitute 2.3, negative 2.45 times 2.3 is negative 5.635, and when we add 11.83, that gives us 6.195. So when x is 2.3, our line of best fit estimates the y value to be 6.195. Number 3, how does the estimated value compare to the actual value from the table when x is 2.3? Well, the real value in the table is 6.2. The estimated value is 6.195. That's a difference of only 0.005. So 5 thousandths of a difference. And if you were to round, it would actually round the 9, would round the 1 up to 2. So the real value and the estimated value are within the rounding difference. So that is extremely close. Now, number 4, how does the estimated value compare to the actual value from the table when x is 3? So we're going to say y equals negative 2.45 times 3 plus 11.83. Negative 2.45 times 3 equals negative 7.35. And when we add that to 11.83, we get 4.48. In the table, the real value is 3.2. The estimated value is 4.48. That's a difference of 1.28. So this time, there was actually a significant difference between the two. And that's the thing about a line of best fit. The closer the points are to being in a straight line, the better the estimates will be, no matter what value of x that you use. But the more spread out from being a straight line your points are, the less accurate your estimates will be as the value of x changes. So a line of best fit is only an estimated best fit, and it's more accurate the closer those values are to being in a straight line. If you have any questions about how to solve this practice problem, please use class time to ask for further clarification before we move forward. Our final practice problem: which of these scatter plots are best fit by the shown linear model? In other words, which line has the points closest to it throughout the line? And as we take a look, we can see some space here on A. We can see some big space down here at the end on C. And we can see some space here at the beginning on D and in the middle. But if you look at B, B appears to have the points really close to that line. So if I was looking here, I can highlight this line, and I've got points that are clearly outside that highlighter. Same thing on C. When I highlight this line, I've still got some points that are clearly outside that highlighter. And when I try it on D, I can clearly see I still have some points outside of that highlighter. But when I look at B, I can get all the points within that highlighter width of the line itself. So B is the scatter plot that is fit best by its line of fit. So we are going to end up with estimated values that are really, really close to their real values when we compare them. If you have any questions about anything we went over in this lesson about lines of best fit, please use class time to ask for further clarification before we move on to lesson 6.